Okay, so as we have on the screen, our title for the event is called Understanding the Impacts and Implications of Keeping the Lights On and Off, Tracking the Progress of Access to Electricity for Sustainable Development in Nigeria. I know it's a mouthful, but I guess we want to capture what I guess our research focuses on. And like I mentioned, there's a team of researchers at the University of Strathclyde. It's a cross-faculty project funded by the Strathclyde Group, which is part of the Researchers Group program. And we're looking into a number of questions regarding this. Next slide. Yes, so I guess to the topic of what we're discussing, I think it's no surprise to any of us that I guess in the last meeting of the UN that the next decade, which is between 2020 and 2030, is a decade of action. However, I think we have seen a number of reports now suggesting that, well, most SDGs are not on the track to being met, including SDG 7, which is on the access to affordability, reliability, and sustainability of electricity or energy for all. And I guess it's probably more important for the case of developing countries, including Africa, sub-Saharan Africa, where I guess most of the challenges in terms of access to electricity have been pronounced or have had a lot of implications. Likewise, in terms of how development has progressed up to now, what are the changes we need to make, and some of the questions we need to, I guess, probably investigate to help us get on track towards meeting some of these targets we have set, which is where we are. Some of our discussions is going to be centered on Astrid. You have jumped one slide. Yeah. So I guess in terms of tracking things, I think what we had as one of our core areas of discussion when we started this project in the earlier stages of it was we really wanted to understand how we can support policy, particularly in terms of understanding the problems around access to electricity, what it means for the society, and how do we better understand where I guess there are some unidentified consequences or implications that have not been covered. And I think we know that internationally there are a number of tracking methods or measures that are already used to assess sustainable development, including SDG 7. However, I think we think it's probably necessary mostly for developing countries, including Nigeria, African countries, that I guess we have national oriented measures that we use to track and monitor SDGs. I think I'll give an example here. I think a good example is the UN's access for electricity for all countries. That is probably very common and readily available. But the challenge is one of the measures that it just says urban and rural. And I think if for Nigerians that are in the room or online, we can agree that it's very difficult to just say you can split a country into urban and regional, or sorry, rather urban and rural rather, to be able to understand the implications. It means that there's some underestimated or overestimated considerations when you're looking at such issues. So it makes it a bit difficult to understand some of, I guess, the hidden implications. I think which brings us to how then do we get the reliable data or useful data that can help us identify these issues, which is what brought us together to be able to look at this issue. How can we do that? Particularly because I think for developing countries, including Nigeria, that while there's progress in terms of building repositories and data sets to be able to do that, the issue is that, well, the digitalization of this data is not as consistent and it's not as fast towards the challenges we really want to address. So we kind of need to look at how we can address that. And this has brought us to a number of questions that we want to address and we have addressed using this project. I think the three fundamentals: how do we actually track and monitor access to electricity in Nigeria? Is Nigeria truly on track to meet this goal by 2030? And if it's on track, are we able to better measure what's happening between the zones and regions across the country? And these questions are kind of underpinned on this three core concept we believe part of the SDG 7. First, accessibility, and then affordability of electricity, and if it's adequate. I think for electricity to be accessible, it has to be available in the first place, which I guess is what underpins all these elements. Secondly, it has to be affordable. People need to be able to purchase it and use it when they need it, and if they pay for it, it should be available. And if it's adequate, how sufficient is it to meet people's needs on a day-to-day basis? Is it available for the whole 24 hours or for just a period of time within the year, and what that would mean? And to address these questions, like I said, where we know that there are challenges in terms of the data, there's still more that needs to be done. However, we believe that there's a role that research can play, particularly in terms of multidisciplinary and cross-faculty or cross-industry interactions. So I think our sources of data we have used is our ground sources, which includes our secondary data that we have collected from various sources that we'll explain in the next slide, National Bureau of Statistics and the likes. And the space data is probably one we have also developed on. I think my colleagues will talk more about that. However, I think we focused on one aspect in particular of space data, which is the satellite lights. While there are other forms of space data that can be used, this was probably our initial starting point for this project, and we look to explore other space data that can be used in the future. And I think we'll discuss that later on. So I think in the first stage, we just collect the ground data that talks about or looks at energy consumption and generation and various social development indicators around poverty, the various geographical locations across Nigeria, and then disclose to tell us more about the distribution and the transmission. And then what we do is we map that to the satellite nighttime type data, if I get the wording right. And then we're able to draw out evidence in terms of where there are maybe more insights we can draw out to inform policy and where questions are emerging and challenges, and then we draw some recommendations from that. So like I mentioned, the ground data comprises a lot of sources that we had to collect data from to reach this. Like I mentioned, this is what the challenge is. However, I think we did the best we could to be able to see how we can make our insights more credible, because I guess that's probably usually the challenge, that we have too many sources to be able to collect data from. Ground data from sometimes there's missing data, or sometimes this probably doesn't commensurate with what is needed for. So we have had to draw from a number of sources. However, I think we probably have done a job to probably just streamline it a bit to what we need it for. So going on to the next data, I'm just going to hand over to my colleague who will talk more about the satellite data.
So welcome everybody. You're going to see me talking like on the window, but you will hear my voice over the usual ether. My name is Astrid Bergmeister, and I'll be talking to you today about the satellite data that we have been used to process and derive the nighttime lights. So what you need to know is basically that satellites can access any point on Earth at any time, basically. And so the satellites that we have used here are a Japanese one and an American one, who both have an instrument on board that is called the Visible Infrared Imaging Radiometer Suite. Oh my God, so many complicated words today. And this instrument is one of a special kind, basically, because it has a channel on board that is called the day and night band, and it is highly sensitive to night lights. So anything that you can see in these images here on the right hand side, basically the anthropogenic lights that we produce that we can see from space. And that is why we can use this instrument, since it is so sensitive to these lights. Nevertheless, the same instrument can do many other things when it comes to remote sensing of the Earth, not only night lights. Oh my God. What you also need to know that when this imager takes a picture, each pixel is at a ground resolution of about 750 meters. So the X and Y axis, so basically when you look at it from on a map point of view, it's whatever goes from east to west, is X, and what goes from north to south is our y-axis. And these axes for 1 pixel have a 750 meter resolution. So when it comes to the specifics, we used a threshold for determining whatever is a light source and what isn't. So when you're measuring this data, you get for each pixel, you get a value. And depending on whether that value lies between these, in this case, 0.3 to 2.8 times 10 to the minus 8 watts per square centimeter and stay radian. You don't need to understand that, but it's just part of what I need to say. So if that pixel value lies within that threshold, then we say this pixel actually contains a light source, so a nighttime light. And obviously, when we're talking about nighttime, that is after the sun has set. And the ideal time to take these measurements is when the sun is basically at the opposite position of the country that we're looking at, which in our case is Nigeria. So we want the sun to be on the opposite side of the earth so that we have the best conditions. What we also want is a cloud-free sky, because once there are clouds, the signal can't penetrate the clouds and we won't see whatever is on the ground. So these are our two conditions. Nighttime, which is usually around like in the middle of the night, between midnight and 3 to 4 p.m., depending on the season. And this is now what we have done. So what we've done is basically to focus on the winter seasons in Nigeria. Why winter? Because it seems to be the season where there are less clouds. So we picked out a few images that were representative of what we could see and that had the least clouds. So what you see here on this slide are examples from the 12th of December in 2016, then 27th of December in the following year, and then a combination of two images. And the conditions that we have is that in the first two images, we have a clear sky and dry atmosphere, whereas on the third image on the right-hand side, we get a more humid atmosphere. And the effect that you get with the lights is that you get more scattering, and the night lights seem to be covering larger areas that they actually are. So we need to be aware of the data that we're pulling out. This is another series of examples, and here also in the second image, north of Nigeria, actually you see like this kind of cloud structure, which is actually fog. And so again, we need to be aware that we're not including FAILS data in our third step, so that we have FAILS information. But what you can actually see really nicely from this data are the southern areas of Nigeria, which have a lot of light, and my colleague is going to tell you more about that. So after the thresholding step, we basically did an analysis creating a light mask. So this is basically determining whether a pixel contains light or not. And that gives you a binary map, which is basically a yes and no image, or each pixel tells you whether there is light, yes, or not, no. And we did this for each year and came up with what you see here on the right-hand side is our light distribution trend, which my colleague Suki is going to tell you more about on the next slide.
Thank you, Astrid. So my name is Suki. So I will just start by giving a little bit of a context, some background. You will notice on the figure to the left, that is an image which we've gotten from the Nigerian National Electricity Regulation Commission, which shows you the 11 distribution companies. So the DISCOs mean distribution companies. So 11 companies that distribute electricity across Nigeria. And on the right, we've got the 6 geopolitical zones in Nigeria. You will notice that the DISCOs, the distribution companies, are absolutely aligned to the geopolitical zones. So for instance, if you look at the Northeast zone, which is the pink colored to the, on the right, the figure on the right, you've got the JOS distribution company, which on the left-hand figure covers 4 states of Bauchi, Gombe, Plateau, and Benue. Now, Bauchi and Gombe are in the northeastern part of Nigeria, but Benue and Plateau are in the north central. So in other words, the DISCOs don't cover the geopolitical zones exactly. We had wanted to do our framework based on the geopolitical zone, but we discovered that that absolute coverage isn't what we had imagined or thought. Next slide, please. So going back to kind of the figure that Astrid presented, which is a time series really of night lights from 2016 to 2019, so 4 years combined to present this singular image. And again, you will notice a number of things. Clearly, there is more electricity availability in urban areas. You will notice that the areas where you've got those concentration of colors, so whether it's blue for 2016 or yellow for 2019, are mainly in urban areas. They coincide with capitals of states and areas where there's more infrastructural development as against rural areas. If you look at the top right, upper right corner, the Northeast, you see a lot of land or a lot of areas where there aren't any colors, which means that, there are no lights detected there. And that tells you obviously that those areas are rural areas where there isn't much infrastructure, whether it's electricity infrastructure or just in terms of human ground cover and buildings. The other thing you would notice is that there is more light concentrated, obviously, as Astrid mentioned, in the southern part of the country. That's where a lot of the power generation assets are located. And then you will notice that in particular, Abuja, which is the federal capital, right in the center, it's got lots of electricity radiance. You've got Lagos at the bottom corner. Then you've got Kano, which is towards the top, and then lots of light in the southern geopolitical zone. So lots of the lights or the electricity that is detected, as you can see clearly, is mainly in the south and then in those state capitals where there's lots of infrastructure. And finally, on this particular slide, we noticed that because we were able to compare the different years, we were able to see that there was a minimal change in electricity supply in the northeastern zone between 2017 and 2018. And that's very important because it means that using this method, we can actually kind of measure how the electricity availability in Nigeria is. And we could see, for instance, as I've mentioned, that between 2017 and 2018, that was where there was a most remarkable change in electricity delivery in the country. Next slide, please. This is now correlating this back to what I mentioned in the previous slide. On the left hand, we have a graph that we got from the National Bureau of Statistics that actually tells us the total energy consumed in 2019 by the 11 DISCOs. Okay, and this is obviously the national grid. And you will notice that the Yola DISCO and the JOS DISCO have the lowest amount of energy consumed. Those are 2 DISCOs that cover the northeastern part of the country. So that again, that correlates back to what I mentioned earlier in the previous map. And then if you look at the figure on the right, we were able to, there are a number of things there, but what I want to focus on is the normalized mean radiance. In other words, so to say, the brightness of the lights that we see from the satellites. And we've got the 6 geopolitical zones on the x-axis. You've got those small red dots that tells you the normalized radiance. And you will notice that there is a line, red line that cuts across that gives a threshold. You will notice that the northeastern zone has the lowest level of radiance. Again, that is correlating right back to what the satellite nights shows, the fact that there is less radiance or availability of electricity that is spotted from the satellites in the northeast, and that correlates with the actual ground data produced by the distribution companies, which is coming from the power that is generated within the country. And then obviously you will notice that the south-south and the southwestern parts, geopolitical zones, have a higher radiance level. Again, corroborating the fact that there is the greater availability of light as detected by the radiance in the southern part of the country, and particularly in the south-south and southwest. Next slide, please. And then we try to also get additional insights from these satellite night lights, and we kind of correlated that with some population data, in this case, population density. On the left-hand figure, you will see the population, you see the satellite night lights map, okay? And then we've kind of picked out some particular areas. Point C is the Kano area. Point B is the Federal Capital Territory area, Abuja. Point A, point A is the entire kind of south-south and southwestern part of the country. And then we've also picked out Lagos in particular. Now, correlating that with the image on the right, where we've got the population density map, we've kind of identified the same areas that you see on the map, the figure on to the left. Lagos, from the population density data that we've got from the National Bureau of Statistics and other sources, has the highest density, population density. And you will notice that also the satellite night data radiance is highest in Lagos. So there's a correlation really with the population density and even the intensity of the night lights that is detected by the satellite sensors. And then you notice obviously the FCT got, in the northern part of the country, obviously, you've only got the FCT and Kano having, considerably large level of radiance, whereas most of the radiance is seen in the southern part of the country. And as a matter of fact, we picked out that there are only 8 states that have got a mean radiance above the average. And those states, out of those 8 states, 7 are in the south. So Lagos, Delta, Rivers, Bayelsa, Edo, Ogun, and Imo. And then Abuja is the only state or kind of area within the north that's got that radiance above the threshold. So you can see that really the satellite night lights is giving a good estimate of the electricity data that is generated on the ground from the original source. And I'll now hand over to my colleague Aisha, who will speak a bit more about the ground data correlation.
Okay, thank you very much, Suki. My name is Aisha. So what we did was we sought to map the radiance, the SNTL data to other socio-economic and developmental, human developmental data, in that this may tell us something about electricity energy access in Nigeria. We first of all mapped poverty via the multiple poverty index, which is the multidimensional measure of poverty in Nigeria. And then we also mapped what people spend, that is what they spend as a share of their total expenditure on light and fuel energy to generate energy. So what we found is that there is this great disparity in terms of poverty between the northern and the southern states of Nigeria via the MPI, which is shown as a blue bars there on the chart. We see that the southern states are much, much richer than the northern states in Nigeria. And this is something that the World Bank has also taken note of, especially the slow decreasing rate of poverty in the northern states. So for instance, we see Lagos there at the left of the chart having just 1.6 MPI, which is a very rich state. And then at the end of the chart there, we see Yobe having a very high poverty, about over 54%, a variation of over 60% between the two states. Now, what we saw also is that this high poverty rate is corroborated by low radians within the states that have high poverty. And this is consistent across most of the states, except for those within the Southeast, like Abia, Anambra, and even states, which seem to have, they are evidently rich, but they also have low radians. Now, when we looked at expenditure, we saw that overall, more than half of the states, 21 of them, are spending above average on the electricity. And then this are usually high radiance states also. But we find this direct corroboration between these 21 states in terms of radiance, where we see 15 states actually spending low on electricity and also having low radiance. And then 6 states actually spending high on electricity and also having high radiance. And the 19 states actually that are spending above the average Nigerian national average on electricity, that's the dotted green lines on the bars there. 16 of them are actually all rich states, and they're all from the southern parts of Nigeria. And all but 5 of these 19 states are all having low radiance. So it's a clear pattern there. And then when we look at those states that are above the mean radiance for Nigeria, 6 are high spenders, and they are all states, but we see Edo among them having the highest spend of over 6.6%. But what is interesting is that the highest spend in terms of electricity energy is seen in the low states that are evidently rich. They're spending high, but they also have low radians like Oyo, Ondo, and Osun with over 6.9%. So this analysis speaks a lot to affordability. And when we looked at access to electricity from any source, we see that it further contextualizes what we found here. Can you go to the next slide, please? So we looked at the access to electricity from any source for the Nigerian population. We know that Nigeria has not really met its target of providing access to electricity to at least 75% of its population, as was planned earlier. They're now at 64%, which is an advancement from where it was in 2015, which is 40%. So when we looked at access, we still again saw this greater variation between the states. There's a sharp decline there, as you can see on the chart, with Lagos having close to 100% of its population accessing electricity from any source. And at the end of the chart there, we see Taraba with just 19.2% of its population having access to electricity. And when you look at this chart, you can see that of at least the 21 states that have at least 50% of their population having access to electricity, only 8 seem to have high radiance. They include states like Abuja, we can see there, Edo, and Ogun and Rivers states. And interestingly, these are high spenders on electricity energy, and they are also the states that are located within the DISCO, that's the distribution company zones that supply and consume the highest energy. They include places like Ikeja, Abuja, and Ibadan DISCO zones also. Can you go to the next slide, please? So we also looked at then, in terms of access, we then looked at what people use as their primary source of electricity, whether they depend on the national grid or other sources of generation like solar and fuel power generators. We can see from the chart there, the blue bars show the population that depend on the national grid. This means that in general, the Nigerian households depend more on the national grid in all states actually than they do on other sources of generation. And we see that you see Kano with its high concentration of radiance, which we saw in the previous chart, having over 99% of its population actually depending on the national grid as their primary source of electricity. And most of the states that are above the Nigerian average, which is 80.5%, are all having low radiance, apart from states like Lagos, FCT, and Abuja, which is a clear inverse relation here. And we see also in this chart that in general, it's the northwestern and northeastern states of Nigeria that have the highest use of the national grid as a primary source of electricity, but with low radiance. But we see a change when we look at the southwestern states, where they have high use of the national grid as a primary source of electricity and also high radiance. So this, in a way, ties to the question of whether the electricity that people get is actually adequate for them to use, that it is sufficient for day-to-day use to support their subsistence and day-to-day living. So, the next slide. So we looked at consumption of electricity as per the hours of the day that people get electricity, and also the hours of the night between 6 to 10 p.m. that people get electricity. And on average, Nigerians get just 7 hours of electricity in a day. And this gives us a large gap of 17 hours to support 17 hours gap, to support daily living. So this means that for over 70 hours, most of the states in Nigeria don't get electrical energy to support anything that they do. And we see the highest hours, surprisingly, in a state that has very low radiance, which is Yobe, our 17 hours, surpassing even states like Lagos and FCT and Delta states. And another interesting fact is that these states, the state that has the lowest and highest radiance, which is Yobe and Lagos, are also those that have high access to electricity. They also depend a lot on the national grid as a primary source of electricity, but seem to have the highest and the lowest radiance, which is quite interesting. And of all the high radiance states that are above the national average, only Delta seems to have electricity for more than for more than 7 hours in a day. But one thing also that we notice is that some of the states that seem to have high radiance but have low hours per day are also rich states that are also high spenders, like Abia and Ebonyi State. They seem to spend a lot on electricity, which seems to now reinforce the discussions and studies conducted to show Nigerians have high dependence on self-generation of electricity, that includes solar and most especially fuel-powered generators. The Northwest and the Northeast states here also in this analysis are those that have the highest hours per day and night also. And this analysis is collaborated across all the states, the high radiance states. In fact, all of them have at least a 3-hour gap during the nighttime, which is shown as the green bars there on the map, without electrical energy. So there is a clear disjoint there between electricity, or rather the hours of electricity that people get, and the light that we analyzed and accumulated in our data. Thank you very much. I will now hand over to my colleague Fisayo so that she can conclude on key findings and messages. Thank you.
Okay, I think we're getting close to the end, and I think I probably did mention that earlier, that if you have any questions, you can put them in the chat, and I think we'll also get to that point shortly after this. Okay, so I think we've had a lot, and I guess we've received a lot of insights from the presentation so far, but I guess just to summarize on what the key findings are and probably some of the key messages we believe, I guess, stakeholders and policymakers should probably have at the top of the agenda and to consider, and also, I guess, a challenge also for the research community as well in terms of further analysis we might want to look into. I think first, I guess, which is probably more generic, is that we have noticed that in having to get all of the data, especially with the ground data, that I guess there's this continuous trend of unutilized and stranded assets as a result of the significant mismatch between the power that is generated, what is transmitted, and what is supplied. And I think that's probably one of the challenges we're already having at the moment, and I think it's probably one that needs to be looked into further. We still see that there's this disproportionate spread of electricity across the country and across the state capitals, across the zones, like we mentioned, with most of the visibility concentrated in the state capitals, where there's probably more industrial development and infrastructure development as well. More so, a large share of household expenditure is spent on electricity, However, because demand is not matching supply or supply is not matching demand, either way, it causes the price of electricity to be relatively high, which is putting more pressure on the spending power of households, meaning that you have to be taking a lot more out of their incomes to be able to spend on electricity. Impact in terms of poverty, poverty is impacted, and there's a likelihood that it can be excavated because I guess there's not evidence of development that corroborates with having to reduce poverty and ways of alleviating poverty. And I think what kind of sums it up also, I guess when we talk about the visibility that is concentrated in the state capitals and or in the industrial regions, I think it's just another evidence to show that there's a big domestic supply chain of the electricity system or the electricity sector as a whole, where there's not a lot of interrelation or interaction with other sectors in the economy. For example, we know that in the north, there's a lot of stuff in terms of agriculture that can support development, but if electricity is not getting to such regions at the scale that is needed to support growth, then I guess we can't, or it might also impact our development as well. So I think these are kind of important issues we need to look into to consider how the electricity sector can play a key part in supporting other sectors within the economy to move the country forward. And in terms of policy narratives and recommendations, I guess these are probably more generic and also cut across some of the developments we have seen in the last few weeks following COP, and also in terms of where we as researchers want to take the work forward to. First, I guess the president did identify this as one of the agendas, that there will be more decentralized electrification sources moving on. However, I think while renewables is already playing a role, there's more work needs to be done in that respect. However, there's also the need to consider alternative fuels as well, things like hydrogen and other sources that can play a role. And I think this is probably my personal opinion, that I believe that it's probably, we kind of at the stage where we kind of have to exploit all sources. We can't really pick one source against the other. We kind of need to exploit as much as we can and as much as is available within the country, and as much as possible reduce importation of sources that might make it more difficult or more expensive for electricity to be available to the population. And that will mean that I guess policies need to probably shift away from having to retrofit or upgrade the national grid, which at the moment doesn't seem to be sufficient to meet the needs of the population. Secondly, I guess there needs to be more, regulation in terms of price caps for electricity to manage fluctuations, and social tariffs to reduce the pressures on consumers as well, because I guess rising prices will also affect their spending ability. Like I mentioned as well, in order not to probably exacerbate the issue of poverty and or where I guess make other forms of poverty kind of rise up, I guess, or widen inequality gaps, there's need that more support and financial schemes should be made available to the population. And I think another point I think we have drawn out is that I guess this is probably more generic across the world, or across, I guess, most developing countries who are looking into having to transition to low carbon solutions or meeting sustainable development goals, is that there seems to be a lot of focus on the technology and the infrastructural requirements, which in itself is very important and plays a key part in it. But I guess we're neglecting the social implications of it, the social implications and well-being impacts on it, remembering that this is a social challenge, it's not just a technological challenge, because I guess technology will keep improving and will keep progressing. But I guess we want to also make sure that society is not worse off because of the pressures as a result of making such transitions. So I guess that's also, I believe, should be top of agenda of policymakers' consideration, that people's well-being should be center of decision making. And lastly, like I said, following up on COP, I guess there's a lot of pressure around it in terms of how we develop. I think we have now that we are aiming for 2060 to support climate change, global climate change actions. However, I think we also need to be very careful that we don't, I guess, import all of the costs and implications of having to import carbon-intensive goods and services into the country that might make it even more difficult to meet our economic and sustainable development goals and projects, progress in Nigeria generally. So I think this kind of sums most of it up. So we're happy to open up to a few questions just after I take this point, sorry, before I forget like we said at the beginning, that we have just focused on night lights here and some of the development indicators, but I guess that there's so much more that can be done with space data. My colleagues Astrid and Suki are probably more specialized in this area. There are other SDGs that can be looked at, if not all, but most of them can be looked at using satellite data. We know that the impacts of COVID has caused, I guess, probably some Nigeria to probably shift away from strategy a bit because the economy, I guess probably there's more focus on economic recovery at the moment rather than have some of these goals as well. However, there's more that can be done. We kind of need to further understand the implications on social well-being, like we mentioned. And yeah, like I said, there are other SDGs that we can also look at as well in terms of poverty, life on land, and climate action as well. So we're happy to open it up to questions now if there's any questions that we have from the audience. And any recommendations and discussions as well.